My name is Charles Warden, and I'd like to go through this blog post describing making HLA type assignments using raw genomic data. So first thing you'll probably notice is this table, where each row is a type of HLA gene, and then the columns are different methods. And so for the first two columns, the raw data being used is SNP chip data. That type of data can come from companies like 23andMe, Genes for Good, or Ancestry.com, or Ancestry DNA. And then the last two come from Illumina exome sequencing, which is sequencing where they've targeted the exons in your genome without sequencing your whole genome. And so for HLA-A, B, and C, the results are all consistent. So I feel comfortable with those HLA assignments. However, for HLA, DRB1, DQA1, and DQB1, there are inconsistencies. And I will get back to explain why some of these are colored in magenta. So first, I'd like to explain something that I myself am trying to learn more about. But it's an important point to try to understand why I'm looking at this data and I'm still trying to work on the interpretation. So essentially, my understanding is that you can have risks that are defined by diplotypes between alleles of two genes. So this is the one I'm going to be discussing, DQ8 positive. And so in order to be DQ8 positive, you have to have one allele of HLA DQA03 and one allele of HLA DQB10302. And these can come from either parent. So this could have come from your mom, this could have come from your dad, and you'll still be DQ8 positive. And if you have both copies with these alleles, then you'll be DQ8. And that causes you, in most cases, to be at increased risk. So for example, if you were DQ8 and you did not have a high-risk haplotype or diplotype, again, from my understanding, then that would not be a very substantial increase in risk. But if you're DQ8, you're supposed to be at increased risk of getting the disease. And if you look at my 23 result, they're saying that based upon one SNP, I'm supposed to be DQ8. Now, again, from what I just showed you on GeneReviews, it's supposed to be defined based upon your alleles from two different genes. And so that's kind of what this whole conversation is about. And this particular image is a little bit confusing in the sense that here's DQ8, and it says the gene is HLA DQB1, but it's a SNP that represents two different genes, HLA DQA1 and HLA DQB1. And so to be clear, this particular position, indicated by this marker, I am confident that I have two Cs. However, it's the interpretation of that two Cs and whether that extends to the full gene sequence of these two HLA genes, this highly variable region, is what I'm trying to discuss and understand better. So now let's go back up to this table and look for those two alleles that define you as being DQ8. And so if you look at the raw SNP chip data, you don't actually come up with any results, I would say, on DQ8, or even have one DQ8 diplotype. However, with the exome data, you have one method that would match the one SNP that's considered for my 23andMe report, and you're another method that indicates I would at least have one DQ8. And in general, it might be nice to have more of the sequence data rather than that one SNP, but a limitation might be the length of the Illumina reads, and this being a highly variable region. So something else that there's two reasons that can be complicated. One is that you have to design targets to do sequencing for exome sequencing, and then for any type of Illumina data, the read may be shorter than the length of the HLA gene. But for the first thing, we're going to say, let's just focus on the fact you had a target of sequencing. It's going to be in a variable region. It is in a highly variable region. So if we look at Illumina whole genome sequencing data, and if anyone's looked at my data, they may have noticed I've had Illumina whole genome sequence data for a while, but I got sequencing.com data because I wanted to be able to have unaligned reads. And I believe there are currently other ways to do this, but the problem was that I previously had raw data provided for the form of chromosome aligned reads, and my reads don't align very well to the reference genome in this highly variable region. So being able to get all the reads that were generated, regardless of whether or not they aligned to a particular genome reference, was important for reanalysis. And so for HLA, A, B, and C, I still feel comfortable in the results. Strictly speaking, there might be some amount of ambiguity, but I think this may be more of a methods issue than really questioning either the A, B, or C results. But if there's any ambiguity here, that does give you some reason for pause. And then for the HLA, DRB1, DQA1, DQB1, unfortunately, at least if you look at the data this way, it looks like it's about the similar level of confidence as the exome data. There are two ways where I would get a DQ8, DQ8 result. So for both copies of my chromosomes, even though you can actually define it from one allele from one chromosome to the other, but if you're homozygous, then it's got to get both your chromosomes. So it is possible this matches the conclusion from the 23 report, which was based upon one SNP, but there's some ambiguity. So I was still not completely satisfied with that. So I also have some even more recent, I believe, PacBio HiFi data. And so this is longer read data. So the reads, each individual read is larger, and you may be able to get the whole HLA gene within a fragment that you sequence, but it's lower coverage than the other data. It's only about 10x coverage. And so at the moment, I'm not sure how much of its methods limitations versus what might be helpful to have more reads. At some point, probably in the more distant future, I'd like to have some more long read data, and doesn't necessarily have to be PacBio HiFi data, but other types of long read data. Hopefully that can be more successful in accomplishing the goal of trying to be more firm about saying whether sequencing-based method matches the conclusion from that one SNP in the 23 report. Because with HLA A, B, and C, now it's actually less clear for the HiFi data than the Illumina data. So that's really the issue, that if you go look at the genes I'm trying to say, it's where I was hoping to get even more confidence about whether or not I'm DQ8 with a non-risk allele, or whether I'm DQ8, DQ8. I think that the two interpretations that I would be trying to decide between. The long read data was unfortunately not really helpful at this particular moment, although part of the reason was together is to try to get feedback so that when I'm able to look into it more, potentially I could try other methods. And again, after a sufficient period of time, I'd kind of like to have more long read data, maybe of a different type. And so I also tried to see what people could order in terms of getting something that's specific for HLA. So this gluten ID was really focused on HLA, but the problem was that when they said I was DQ8, it was based upon the one SNP used by 23andMe. So it's not really independent verification where someone's looked at the whole sequence for these two HLA genes and come to a conclusion about, in a clinical setting, about what you are. So I'm unfortunately still not more clear than when I had the exome data, but I do have a bunch more data, so I potentially have more ways I can look at things, and hopefully that can eventually help me out. And even if I eventually get some sort of new type of data I don't have right now, then hopefully I can eventually relook at the Illumina whole sequencing data and the HiFi data and be more confident. But I hope this helps in terms of trying to give it a sense of what sort of troubleshooting you can perform with your raw data. And I hope people enjoyed this presentation, and I certainly enjoy learning more. Thank you very much.